welcome to the deep dive. Today, we're getting right into the strategic thinking that you're going to need to succeed over the next couple of years.
We are. Our source material is the Tech Trends 2026 report.
And it's really a document that's been customized for leaders, for founders, for anyone focused on strategic execution.
And, the whole conversation has just fundamentally shifted. For the past 2 years, it's been, what can we do with AI? All about experimentation, proofs of concept.
Right, the sandbox phase.
Exactly. Now, the mission is singular. It's about moving past those pilots to achieve a measurable business impact and scaling those operations. We're in the production reality phase now.
And that window for catching up is closing really, really fast.
It is.
Now, the information here, what you need to stop doing, what you need to start building, it's incredibly dense. So because of that, we're breaking this deep dive into 2 parts.
We have to.
This first half, we're going to tackle the foundational speed of this new innovation and the first 3 critical trends. So that's the convergence of AI and robotics, the agentic reality check.
Which is causing so many pilot failures.
Exactly. And finally, the huge infrastructure dilemma that's hitting balance sheets right now.
And really, it's that foundational context that matters most. I mean, you have to understand the pace of change before the trends even make sense.
Okay, let's start there, because the numbers on innovation are, well, they're staggering. We're talking about innovation that compounds exponentially.
Right.
This is where you feel that urgency. I mean, think about historical adoption. The telephone took 50 years to reach 50 million users. 50.
Like a lifetime.
A leading generative AI tool, though, reached double that, 100 million users in just 2 months.
Yeah.
Just try to wrap your head around that scale.
It's almost an instantaneous shift in human behavior. And that same tool now has over 800 million weekly users. That's about 10% of the entire planet using one type of AI routinely.
So what's driving that? Why is this growth exponential and not, just linear?
That's the key question. It's not just a popular product. It's what the report calls a systemic, multiplicative flywheel effect.
Okay, so tell me more about that compounding effect, because that sounds like the engine behind everything we're about to discuss.
It is. The growth is self-reinforcing. So improvements in the models themselves, they enable more sophisticated applications.
Yeah.
More applications generate these massive new streams of proprietary data. More data then attracts way more investment from both VCs and corporate budgets.
And that investment builds out the infrastructure.
Exactly. Better infrastructure, which in turn speeds up the models again. All of these things are accelerating each other at the same time. The consequence for you is that the half-life of knowledge in AI has shrunk from years to, months.
And that speed, it really means one thing if you're a leader. Your traditional sequential improvement processes, they just can't keep pace.
They can't.
If you try to just automate what you're already doing, step by step, you'll be outpaced. Competitors are rebuilding from the ground up.
So success isn't just about the tech anymore.
No, it hinges on your willingness to redesign core processes. Sometimes that means tearing up the blueprint and starting completely over, not just paving the old broken cow paths.
That's where strategic clarity is everything. I saw a great quote from Broadcom's CIO on this.
Oh.
He said, you have to anchor your AI spending to specific business problems. You have to be able to measure the value you want to get out of it.
So no more science projects.
None. You need a quantified outcome, a 20% reduction in support time, a 5% increase in throughput. Without that, you're just investing in cool tools with no demonstrable return.
And this pressure to tear up the blueprint, it's leading us to the first big trend, where the digital world really starts bleeding into the physical one. Let's talk about trend 1. AI goes physical.
Absolutely. This is where intelligence moves beyond the screen, beyond the spreadsheet. We're talking about physical AI.
Define that for us.
These are systems, robots, autonomous vehicles, drones that perceive, learn, and operate autonomously in these really complex physical environments.
So they're not just pre-programmed.
Not at all. They adapt their behavior based on real-time sensory data. They are learning systems.
And this is already moving past niche applications.
Right.
It's hitting industrial scale and fast. What's the evidence we're seeing today?
The scale is just immense. Take Amazon. They've already deployed their millionth robot in their fulfillment network.
A million.
A million. And crucially, they're all coordinated by this AI model called Deep Fleet. It's like the air traffic controller for the warehouse floor, and it's improved their fleet efficiency by about 10%.
And a 10% gain at that scale is.
Yeah.
It's a massive, massive number.
Huge savings. And it's not just forklifts. In manufacturing, look at BMW.
What are they doing?
Their factories are using autonomous vehicle tech, the same sensors and mapping from self-driving cars, to have newly built cars drive themselves through the factory.
You're kidding.
No, they drive themselves for kilometers, through production routes, to quality testing, to the finishing area, all without a human driver touching the wheel.
Wow. Okay, that leads right into what the report calls the humanoid frontier.
It does. And the reason the humanoid form factor is so compelling is, it's actually really simple.
Why is that?
The world is built for human bodies. Doorways, factory floors, tools, stairs. Everything is designed for our shape. So a general-purpose humanoid robot can, in theory, just slot right into our existing infrastructure.
No expensive overhauls. That makes the cost to deploy incredibly attractive. I saw a UBS projection that by 2035, there will be 2 million humanoids in the workplace.
That is an explosive trajectory for a technology that, to many people, still feels like science fiction.
So what's the technical bridge that's making this possible now? What are the key technologies?
Okay, for any managers listening, there are two terms that really matter here. The first is Vision Language Action Models, or VLA.
VLA, what does that do?
This is the key. VLA integrates what the robot sees, computer vision, with how it interprets commands, natural language processing, and how it acts motor control. It lets the robot think contextually about how to solve a new physical problem.
So it's not just repeating a task, it's find that tool I just dropped, or reorganize this shelf.
Precisely. It gives them that contextual intelligence.
But what about the processing power? To make those decisions in real time, safely. That seems intense.
It is. And that brings us to the hardware side. Onboard computing, we're seeing this proliferation of specialized processors called neural processing units, or NPUs.
MPU.
They allow for really low latency, real-time decision-making right on the robot itself. You absolutely need that local processing for safety.
Right, because if an autonomous car has to call the cloud to decide whether to brake,
It's a catastrophe. Exactly. NPUs make the intelligence local and immediate.
this all sounds pretty smooth, but the report does highlight some big strategic barriers to actually scaling this. What are the main challenges people are facing?
There are two big hurdles. First, there's this persistent gap between training in a simulation and how the robot performs in the messy real world.
So what works perfectly in the simulation?
It might fail in reality. You can train a robot to grab a wrench 1,000 times an hour in a perfect simulation, but a real wrench might be greasy or the lighting is different. That last 10% of the problem is incredibly complex.
So that slows down deployment. What's the other risk?
The second is a human risk, actually. It's the danger of what experts like Ayanna Howard call behavioral overtrust.
Overtrust.
Yeah. When a system that can apply physical force performs well, we humans tend to start relying on it too much. The consequences of a physical error, though a robot arm swinging incorrectly, can be irreversible. So you have to plan for really robust human-in-the-loop protocols to manage that trust gap.
Managing the physics of AI. That leads us straight into managing the mental load of it. Trend 2, the agentic reality check.
Yes.
We're talking about AI agent software that operates autonomously, but businesses are hitting a major wall here.
A huge wall.
The enthusiasm is high 38% of organizations are piloting these things. But the report says only 11% actually have them in production. That's a massive pilot-to-production gap.
It is a profound gap, and Gartner actually predicts that over 40% of agentic projects are going to fail by 2027.
Wow. Why? What's the main reason for failure?
It comes back to what we said earlier. Enterprises are just trying to automate their existing, often broken processes. They aren't redesigning their operations to be agent native.
So we're back to that don't pave the cow path idea. An agent will just automate 10 bad steps faster, which gives you, what, a slightly faster bad process.
Exactly. The success of an agent depends entirely on how the underlying process is structured. HPE's CFO really nailed this. They realized they had to pick an entire end-to-end process to transform, not just solve one little pain point in a bigger, broken workflow.
Okay, so beyond process, what are the architectural roadblocks? I mean, for agents to work, they need access to everything, right?
They do, and that's a huge problem. Most legacy enterprise systems, they just don't have the modern APIs agents need to interact autonomously, they hit these hard-coded walls and the whole thing just grinds to a halt.
And I'm guessing data is the other nightmare.
It's worse than messy. It's organized for humans, not for machines.
Hmm?
Traditional data architectures, things like ETL processes, they just create friction.
What do agents need instead?
Agents need data that is contextual and highly searchable, so you're seeing this rapid pivot to things like knowledge graphs and vector databases to make information instantly discoverable for this new silicon workforce.
I like that term, silicon workforce. It implies they need to be managed like a new form of labor.
They absolutely do. It is not a one-time software license. It requires totally new management frameworks.
Like what?
Well, two critical things. First, you need specialized FinOps financial operations to track the unpredictable costs of token consumption. An agent is always on, always consuming compute. Those bills can spike.
Okay, so cost management. What's the second?
Governance. You have to create policies that define graduated autonomy levels. You need clear rules for when an agent can just observe, when it can recommend an action, and when it's allowed to execute a transaction all by itself.
Can you give us a real-world example of a company that got this right?
Toyota is a fantastic case study. They built an agentic tool to give them real-time visibility into vehicle delivery ETAs.
Okay.
And this wasn't just about speed. It eliminated the need for their staff to manually check between 50 and 100 different mainframe screens just to get the information for one car.
So they didn't just automate the checking. They redesigned the whole process to create a single dashboard of truth.
That's it. Transformation isn't about automating the call center script. It's about eliminating the need for the call in the first place.
Which brings us perfectly to the third strategic trend in the report, the AI infrastructure reckoning. The basic math of AI is forcing everyone to recalculate their entire strategy.
This is where we hit what the report calls the inference cost paradox. You mentioned it earlier. Token costs for these big models have plummeted, something like 280-fold in 2 years. But overall, AI spending is just exploding.
Wait, run that by me again? Token costs dropped 280-fold, but company bills are soaring into the tens of millions a month. How does that work?
It feels completely counterintuitive, right? It's like the price of gas goes down, but your company's fuel bill goes up by 10 times.
Exactly.
The reason is high-volume production inference. Inference is the continuous, large-scale use of the models after they're trained. And the explosion in usage has just dramatically outpaced the cost reductions. You're using so much more compute, so much more often, that your total bill is just exponentially higher.
And this realization is forcing a major rethink of the cloud-first strategy that's dominated for the last decade.
A total rethink. It becomes cost prohibitive for consistent workloads. And it's not just about money. There are compelling non-financial reasons forcing this shift too. First is data sovereignty.
Right. Regulations and geopolitics. The need to keep your sensitive data local.
You can't put that data in a cloud provider's data center that's thousands of miles away in another country. And the other big one is performance.
You mean latency?
Exactly. Latency. Real-time applications, robotics, autonomous systems, they need response times of 10 milliseconds or less. That is physically impossible if your data has to travel to a distant cloud and back.
So if pure cloud is too expensive for inference and too slow for real-time systems, what is the new strategic model managers should be building?
The solution is a really optimized 3-tier hybrid architecture. This is how you balance cost, performance, and compliance all at once.
Okay, break down the 3 tiers.
First, you keep the cloud. It's perfect for elasticity, for variable training workloads, and for experimentation.
For the peaks and troughs. And the second tier.
Second, you leverage on-premises infrastructure, your own data center. This is for the consistent high-volume production inference. You run it at a predictable, fixed cost.
When does that make sense?
It becomes a simple ROI calculation. When your projected cloud costs for that workload exceed, say, 60 or 70% of what it would cost to just buy the hardware yourself, you bring it in-house.
And that leaves the final tier, the edge.
The edge is for immediacy. It's where you handle that latency-critical decision-making. You're putting computing capability, those MPUs we talked about, directly onto devices on the factory floor, in the vehicle, out in the field.
What's critical for leaders to understand here is that this isn't just about moving workloads around. You can't just use your old server room for this.
Absolutely not. This shift is driving the rise of the AI data center or the AI factory. These are totally different beasts.
Yeah.
They have a much higher ratio of GPUs to CPUs, advanced liquid cooling, high-performance networking. It's an architecture that legacy data centers simply cannot provide.
So this is fundamentally changing capital expenditure models across the entire industry.
It is. So we've covered three massive immediate shifts today. First, the physical embodiment of AI in robotics. Second, the need for total process redesign for agents to actually work. And third, this foundational shift to a hybrid architecture, all driven by the harsh economics of inference.
And that was just part one of our deep dive into the Tech Trends 2026 report. We've laid the groundwork. The incredible acceleration of innovation and the non-negotiable need to redesign your operations and your infrastructure.
And in part two, we're going to shift our focus to the organizational side of this. We'll dive into what the report calls the Great Rebuild, how the entire technology organization itself has to restructure.
We'll also cover the AI dilemma, which is this paradox of using AI for cyber defense while also defending against AI-powered attacks. And we'll cut through some other key trends you need to track.
You know, the convergence of physical and software intelligence is here. The gap between the leaders and the laggards is growing exponentially. The time for piloting is over.
The time for scaling has arrived. So we really encourage you to seek out the full Tech Trends 2026 document for the complete picture. And make sure you return for the second half of this crucial discussion as we continue charting that path from experimentation to scaled, measurable business impact. We'll see you then.